almost as if right from the start we felt as though the stars were important and that we were somehow connected to them. For thousands of years, we've looked to the night sky as a source of wonderment and inspiration. By watching the daily motions of the sun, the changing phases of the moon, and the stately, predictable, nightly procession of the stars across the sky, we learned how to tell time and how to create calendars in order to regulate our lives. We use the stars as familiar guideposts to help us navigate both land and sea. We created patterns among them to represent the gods and heroes of our various mythologies. And we also gazed into the ink-black darkness and asked some of the oldest and most fundamental questions of all. Where did we come from? Is the universe eternal, or did it have a beginning? And are we alone? Hello everyone, I'm Darrel Heath, the NASA Outreach Coordinator for the Arkansas Space Grant Consortium located on the campus of UA Little Rock. Welcome to the night sky. Due to the finite speed of light, whenever we look out into space, we are also looking back in time. This means that whenever we look at celestial objects, we do not see them as they are right this minute. We always see them as they were at some point in the past. Looking at the moon, you are seeing it not as it is right that very moment. You are instead seeing it as it was 1 1/3 seconds ago. The sun, well, let's just say that if it stopped shining, and it won't for now anyways, you wouldn't know about it for 8 minutes and 20 seconds. The further a telescope can see, the further back in time we can peer. With our best telescopes, we can see billions of years into the past. And from these observations, combined with the knowledge that the universe is expanding, it becomes obvious that the universe was not created as is. Instead, it must have evolved over time from the simple to the complex to become the universe we see today. The so-called Big Bang Theory is the best working model that astronomers now have for providing a scientific explanation for the origin and evolution of the universe. According to current evidence, the universe had its beginning some 13.77 billion years ago from a very dense, very hot, and very tiny state. For reasons we do not yet understand, this very compact and very hot singularity suddenly expanded in size, and in doing so, it gave rise to all of space, time, matter, and energy. But the early universe was far too hot for atoms to exist. Initially, there was just a hot, dense soup of subatomic particles. With time, the universe would cool down to a point where the first atoms could appear, and the first elements, primarily hydrogen and helium, came into being. Sometime after that, the first stars and galaxies would appear. One of the holy grails in astronomy is to be able to see these first stars and galaxies, and we now have the means to accomplish this with the NASA and European Space Agency's James Webb Space Telescope. The telescope is named for James E. Webb, NASA's second administrator. He spearheaded the Apollo program and initiated numerous space science programs, leading to more than 75 launches during his tenure. Development on the James Webb Space Telescope, or the JWST, or simply Webb, began in the late 1990s with a projected launch date in 2007. But due to a variety of reasons, ranging from budgetary issues to technological issues and to the pandemic, things got delayed. Then again, we've never sent a telescope like Webb into space before. It's huge for one thing. The Hubble Space Telescope is about the size of a school bus. The JWST is about 70 feet long, half the size of a 737 aircraft, and its primary mirror is a whopping 21 feet in diameter. In fact, the mirror is so big that it's made to be foldable, origami style, so that it will fit within the 5.5 meter wide rocket that will carry it into space. The mirror is actually 18 individual segments, made from the rare metal beryllium and coated with a layer of ultra-thin gold about 1,000 atoms thick in order to enhance the mirror's reflectivity to infrared. But why does the Webb's mirror need to be this big, and what's so important about infrared light? The most important job of any telescope, whether it uses glass lenses or highly polished mirrors, is to collect light from very distant and oftentimes very faint objects. How much detail a given telescope can provide depends on how much individual photons of light it can gather. A good analogy would be like how a bucket can gather individual drops of rainwater. So Webb's huge mirror means that it's a light bucket of enormous proportions and enormous potential. The Webb's larger primary mirror allows it to collect much more light than Hubble can, effectively allowing it to see further back in time than any telescope now available. The James Webb Space Telescope will be a giant leap forward in our quest to understand the universe and our origins. The telescope will examine every phase of cosmic history, from the first luminous glows after the Big Bang to the formation of galaxies, stars, and planets, to the evolution of our own solar system. Viewed this way, Webb is not so much a replacement for the Hubble as it is an extension to the many discoveries made by everyone's favorite space telescope. As I mentioned earlier, Webb's emphasis will be primarily in detecting light in the longer infrared wavelengths. Well, what's so important about infrared? Well, the light emitted by those first stars and galaxies all those billions of years ago would almost certainly have been within the visible portion of the electromagnetic spectrum. But that's not how we would see them today. Remember, the universe has been expanding ever since the Big Bang. And when I say that the universe is expanding, what I mean is that space-time itself is stretching, and all of the stars and galaxies are riding along with it. Think of a lump of raisin bread dough. Raisin bread. Those raisins are the stars and galaxies. At first, embedded within the dough, those raisins are fairly close together, but pop it in the oven and the dough rises, and the raisins move apart from one another. It's important with this analogy to realize that it's not the raisins that are being stretched apart. It's the space-time dough matrix in which they are embedded that is. All of this is perfectly compatible with Albert Einstein's general theory of relativity. As those ancient stars and galaxies recede away from us, the light they emit gets stretched into longer, low-energy, redder wavelengths. Given the vast amounts of cosmic time since those first stars and galaxies came into being, that light is now only detectable to us within the infrared region of the electromagnetic spectrum. Exactly what the universe's first light from the first stars looked like, and exactly when those stars formed, is not yet known. These are some of the questions Webb was designed to help us answer. So, is that all Webb can do? Oh no, its capabilities include much, much more. With its infrared eyes, Webb will be able to see right through and into massive clouds of dust that are opaque to visible light observatories like Hubble, where stars and planetary systems are being born. Take a look at the Pillars of Creation, one of Hubble's most famous images. What you are looking at is just a small part of a much larger cloud of gas and dust known as the Eagle Nebula, located some 7,000 light years away in the constellation of Serpens. This cloud of gas and dust is what's known as a stellar nursery, a place where new stars are being born. In this image, Hubble is showing the pillars in visible light, but what we want is to be able to peer inside those clouds and see what's going on. Unfortunately, the gas and dust is impervious to visible light. The good news is that Hubble has limited infrared vision, and infrared light is able to penetrate through the surrounding dense clouds of gas and dust. Now, take a look at the pillars in infrared. Look at all the stars that we were unable to see before. In this image, Hubble was able to see the heat or infrared light those newborn stars are emitting, but was kept hidden to our eyes from the cooler dust clouds. Now, just imagine what Webb will be able to see with its much sharper infrared eyes. We will be able to see inside these dusty cocoons in order to learn the secrets of the creation of new suns and their planetary families. And if that doesn't float your boat, then check your pulse. But I've saved my favorite Webb capability for last. With the James Webb Space Telescope, we may finally learn whether or not we are alone in the universe. Right now, we know the existence of more than 4,000 exoplanets, alien worlds orbiting stars other than our own sun. Thousands more are awaiting confirmation. Webb will be equipped with spectrometers. A spectrometer allows us to analyze the light from objects, and part of the information we can glean from such analysis is the chemical makeup of whatever it is we're looking at. In the case of exoplanets, Webb can watch whenever one passes in front of its parent star. As the exoplanet does so, Webb can capture the light being filtered through its atmosphere, and this can tell us what gases are present. It might just well be that we can pick up chemical biosignatures that would indicate the possible presence of life. Confirmation of life beyond Earth would be one of the most important scientific discoveries of all time, and I hope to see the day when it happens. The James Webb Space Telescope will be launched in October of 2021. However, Webb will have many hurdles to overcome, and NASA is cross-checking every component before launch to make sure all is well. If the mirror or protective sun shield does not deploy correctly, or if any other bit of tech goes awry, there will be no way to fix it. In order to escape the infrared heat from the Earth, the telescope will be put into orbit some 1 million miles away. But if it all goes to plan, you can expect Webb to make discoveries that will change our most fundamental understandings of the universe and our place within it. Before I go, I just want to let you know that if you are a formal or informal educator and you want to incorporate some of the science of the James Webb Space Telescope into your lessons or programs, please visit the JWST's website at the link you see here. Not only do you get a great overview of the scope and its mission, there are also a wide assortment of lesson plans and activities for every age group. It's great content and it's all free, so please make use of it. Until we meet again, take just a little bit of time to step outside and look up in both awe and wonder.